3, 2, 1. Hey class, welcome to FRM 110, Principles of Fermentation. My name is Joey Medeiros and I will be guiding you through the fermentation principles and kind of get you down through the road and into the world of brewing. A little bit about myself. I am the co-owner and one of the brewers for Hopkinsville Brewing Company. You'll meet my partner in crime here, Kate. She'll be teaching one of your classes as well. I am a graduate of the South College Brewing Program at Knoxville. That brewing program has since dissolved and has become its own standalone class. It's a brewing and distilling program and it still remains in Knoxville. I am retired out of the Army, did 26 years, and towards the last half of my career or so I really started getting into the craft beer world. I have been brewing for 6 years. Most of it's been here at Hopkinsville Brewing Company. My first home brew was actually in the summer of 2006. It was a Mexican ale. Back then I drank Corona beer. At $1 a bottle, that got a little pricey. It wasn't until I met some of my homebrew friends that they showed me how to homebrew. And I was making something very similar to a Corona. I made the Mexican ale. And it cost me about 48 cents a bottle. So significantly cheaper, and hence the beginning of my craft beer world. I really don't have a favorite beer. I like all beers with the exception of Hefties. It really just depends on the season or what I'm doing at the time. I certainly don't want to drink a heavy stout while I'm trying to cut my grass in the middle of the summer. Alright, so one of my pet peeves is the term brewmaster. So I'm going to get my soapbox here real quick. First and foremost, brewmaster, that's reserved for those that are truly brewmasters. Folks who've been doing this for decades. They know all the information. They can talk you through any problem without referencing material. They've just seen it all. They've done it all. Much like you would have a master electrician or master plumber. Same goes with being a brewmaster. I don't care what brewery you're in. I don't care what job title they gave you. If you're in this class, you're probably not a brewmaster. But quite honestly, I don't consider myself a brewmaster either. It takes years to really get to that level. For this class, we'll be using 2 books. We'll be using the Yeast book here, and we'll be using the Brewer's Companion. This book here is a little bit more for templates and spreadsheets, kind of explain things a little bit more in depth. Whereas the first book I showed you, that's going to give you a lot of the data that you'll see, a lot of things that we'll cover here. Some of the objectives for this class. First thing we'll cover in this session is going to be yeast and bacteria overview. We'll also talk about how to choose the right yeast and what yeast do you really want. In later classes we'll talk about yeast management and how the health, viability, and the pitching of yeast has an impact on your beer. We'll talk about mash and yeast and how they correlate and how some sugars react differently with yeast and what your outcome is going to be. We'll talk about oxygenation. We'll talk about fermentation, both open and closed. We'll talk about different phases of fermentation, the lag phase, the exponential and stationary growth phases. And we'll talk about maturation and flocculation and what does that actually mean. We'll talk about harvesting yeast towards the end of your fermentation, and we'll talk about carbonation and packaging and how it's done naturally or if it's forced. And we'll talk about planned and unplanned carbonation and some of the bad things that can happen with that. Alright, so moving right into cells. First and foremost, cells are the absolute building block for all living things. It is the smallest of small. You really need a microscope to see these things. And the study of cells is cytology. So starting at the beginning, all things are broken into categories and hierarchies. So starting with the biggest category, you get the kingdom here. You see bacteria and yeast. These are the 2 things we'll talk about most in our class. Bacteria has its own kingdom, and you can see as it gets smaller and smaller and smaller to Yeast and Lactobacillus, which we'll talk about. And then yeast actually has a different kingdom. It falls in the fungi kingdom, and you'll see we'll talk all the way up to our yeast. Comparing the 2 side by side, on the left-hand side you'll see bacteria. Bacteria is absolutely the smallest organism that out of the 2. And then it has no nucleus and it has no organelles. It is simply bacteria. And when we talk about bacteria, we're going to talk about Pediococcus and Lactobacillus as the 2 key bacteria we'll talk about. There are others in the brewery that you'll find. And on the right hand side you've got your yeast. The yeast is the larger of the two. It does have a nucleus. It does have organelles and other small components within the cell walls. And when we talk about yeast, we're going to talk about ale yeast, which is Saccharomyces cerevisiae, and we're going to talk about lager yeast, which is Saccharomyces pastoranus. Previously, it was called uvenum or Carlsberg genius. And we'll also talk about Brettanomyces. A lot of people confuse Brettanomyces as a bacteria, but it is in fact a yeast, and that's where it falls within the hierarchy of things. Alright, so yeast. If you was to look at a microscope at yeast, this is what you're going to see here. They're very small, and there are tons and tons of them. If you want to kind of look at a little animated picture here, you can see that it has other organelles in here. It has some Golgi, it has some mitochondria. And then you'll see this little bud up here. So this is actually the yeast that's getting ready to reproduce. Yeast reproduces, creates more yeast, and as it goes through the stages here, you can see that the bud actually breaks off. If you look at this picture here, you can actually see where a bud is starting to break off. And this is your bacteria. You've got your Lactobacillus up top, again looking through the microscope. You can see the Lactobacillus is rod-like, and they tend to be in chains, whereas your Pediococcus is a little more round, and it's oval, and they're out there as well. And again, here's your animated view. You can see there are no organelles inside. It's simply a bacteria cell. Alright, our Lactobacillus. So your Lactobacillus is found in the early stages of fermentation. It prefers temperatures of 95 to 112 degrees. It has a pH, or prefers a pH of 4 to 5. And some of the byproducts you're going to get out of Lactobacillus is going to be lactic acid, acetic acid, which is like your vinegar, and you'll have diacetyl. Again, it's never a pleasant thing to have in most beers. Now I say most beers, but we'll talk about how it's actually used in lambics, sours, and Berliner Weisses. Lactobacillus is a key component for that. As you start getting into the beers that you're not wanting, you'll identify this as Lactobacillus because the pH will decrease. The beer will get very turbid. And again, we talked about the optimal conditions. Now, Pediococcus, the one that's really not favored, you'll know when you have it. It smells of gym socks, it smells of goats and horse blanket, and just unfavorable all around. It'll create the beer to be very ropey, very sick-like. Its optimal conditions are a little bit cooler. It sits at about 70 to 77 degrees, and it'll bring a pH, or worst likes to work at a pH of 4 to 6. So if you'll open up your Brewer's Companion book to 11-4, you'll see a nice little spreadsheet in here, which you're not going to be able to read. You see a nice little spreadsheet in there that kind of lays it all down and some of the symptoms and problems. It's a great reference material, as many other things in that book are. Alright, different yeast types. We've talked about bacteria. Let's talk about yeast for a little bit. So yeast, you can break it down into ales and lagers. We'll talk about some of the characteristics, and I'll give you some examples. But there are literally hundreds of thousands of different yeast out there. Yeast has been around for a very long time. It has actually been documented to be used in the Egyptian times. It has been recorded and found. But it wasn't until 1680 when Antony van Leeuwenhoek first identified yeast on a microscope and could actually identify it. But it wasn't until 1857 when Louis Pasteur identified the yeast process and the fermentation process and what its role was in creating beer. But even today, you'll see that there are lots of yeast labs out there that are creating different strains. They're making their own, they're studying their own. So as time goes on, you will be exposed to different yeasts. So yeast itself, it has a very direct impact on the beer flavor. As you look into your yeast packet and try to figure out what you're looking for, you're going to hear some common terms. What type of yeast is it? Is it a dry yeast? Is it a liquid, a slurry? Your dry yeasts are going to be very granulated, much like sugar, whereas your liquid is just that, a liquid. And a slurry of yeast is nothing more than the yeast that you pull off a brew, and you can reuse it later on. So yeast is reused many times over. We'll talk about flocculation, which is how the yeast settles out, and attenuation. So attenuation is the yeast effectiveness and how much sugars are being consumed. Other terms that you'll see on your packages is your temperature and what that range is and what the optimum range is. Just because it goes to a certain range doesn't necessarily mean that it's going to be the optimum result. And you'll hear things like flavor and dry, whether it's clean, complex, and what phenols or diacetyls are available, and what you'll get out of your fermentation. So here you'll see two different packets of cephal yeast, US05 and US04. So it says right here, dry ale yeast. It tells you it's a dry yeast. And then it talks about some of the characteristics and the temperature ranges that we just discussed on the previous slide. And you can compare that with S04 right next to it. You see the temperature range is slightly different. You see some of the characteristics are different. So again, different yeasts have different characteristics and have an impact on your beer. If you go to Northern Brewer website, when they talk about YS 2575, this is their little write-up. This is not necessarily on a package, but this is found on the website. And it's for a Kolsch yeast, and they'll talk about temperature ranges and attenuation and what the ABV tolerance is. Most beers are sitting around 5 to 7% ABV, whereas this yeast here can go to about 10% and still be effective. So ale yeast was the first beer yeast to be identified. Lager yeast was identified a little bit later when they started seeing differences. Its scientific name is Saccharomyces cerevisiae. It is a top fermenting yeast. That is, the yeast sits up on top of the wort and becomes beer, and you'll know that by the Krauser line. You can't necessarily see it in this picture here, but your Krauser line is going to be right here. It's going to be real dark and a little bit harder. It's going to stick to the wall. 75% of our beers are going to be ale yeast, or ale products. So the vast majority of our beers are going to be ales. Ale is typically fermented. Temperatures of 64 to 72 degrees. I've already talked about how it sits on the top of the wort as it ferments. Some examples of the ales are your stouts, your porters, kolsches. Those beers there are typically ale yeast. If you click on this link and go to the White Labs Yeast and Bacteria Pack, you can certainly see all the different styles that are out there. There's more than one yeast. Certainly take a look at it and learn about the different yeasts. So now lager yeast. Its scientific name is Saccharomyces passeranus. The name has changed over time, and as both these names here, it is known as a bottom fermenting yeast. So the vast majority of the yeast settles towards the bottom of the wort, and that's where the fermentation process begins. Less than 25% of the beer population are going to be lagers. They take longer to make, whereas the ale yeast just cranks out a little bit faster, about 3 to 4 weeks. Whereas a lager yeast, it could be 6 weeks or more for it to fully ferment. Temperature range is 43 to 59 degrees. That's where the lager yeast ferments best. And a couple of examples of beer for that are your Pilsners, your Marzens, or your Oktoberfests, your Bock beers, or your Mexican and Vienna lagers. And again, White Labs also has information on their lager yeast. Go check them out. There's different types. Other yeasts that you'll see out there, we've talked about Brettanomyces. So Brettanomyces is going to give you a horse blanket taste. It's going to be very barnyard-like. Don't ask me why they think it tastes like a horse blanket, because I personally don't lick horse blanket. But that's the characteristic, that's the description for it. And it's also caught in the wild. You'll see some places that'll actually capture their own wild yeast and use it in their fermentation. And then finally, you'll see a hybrid of yeast. That's nothing more than your ale yeasts that are lagered at cooler temperatures, or vice versa. And it's certainly a smaller, rarer occasion. Most commonly known is the California Common Ale. That's that ale yeast that's fermented at lager temperatures. So here's some of your yeast examples. We've already talked about White Labs, and hopefully some of y'all have gone to that website and checked out their website. You've got Fermentus that makes Ceph-Ale, and they make Ceph Lager as well. And then you've got Lalamin. They make yeast and they make bacteria for fermenting to make sours. So we've talked about yeast. Now, which yeast do we use? There's a lot of considerations for choosing the right yeast. You know, are you looking for a higher ABV? Are you looking for a clean beer? Are you looking for an estuary beer, full body versus dry? And then finally, you know, do you need to stick to the guidelines or can you just freestyle? Guidelines are used for competition. So if you're going to send a beer to a competition, certainly follow guidelines. And there's information out there for you to know exactly what yeast to use. Or if you're running a brewery like myself and Kate, we don't always follow the guidelines. It doesn't always fall within that guideline. You can use different yeast. If it's a great beer and your customers are drinking it, then it's a good beer. It doesn't have to be per by the book. So, you know, first we're going to talk about, do we want an ale or a lager? Not only that, but what kind of ale or what kind of lager? Are we making a sour? Are we making a brown or an IPA or a Kolsch? Those are the things you want to consider. I know this is real wordy here, but I went to the GABF and I went to the BJCP and I pulled up the same exact description out of their guidelines of what their requirements are if you're competing in these two categories. It'll tell you, for instance, in the BJCP, it'll tell you, including Saccharomyces, Brettanomyces, Pediococcus, it'll tell you the characteristics. It'll tell you the body, dry to full. Everything that's underlined in there can be factors of your yeast. My second example here tells you exactly German lager yeast. I mean, it's simple as that. So you go to your White Labs website, look up German lager yeast, and if you're making a German Pils, 2 category style, 2 competition style, you're gonna use that yeast. It's really simple. The information's out there. And then this is my third and final example here. This is for an IPA. You can see the different notes on different characteristics between the BJCP and the GABF. And by all means, take a look at them, go to those places, and look at their different categories. There are hundreds of different categories out there, and it'll all tell you what you should use. Alright, so this session here was just a simple overview. You need to read in your yeast book here, chapters 1 through 3, and there's a lot more information out there, but again, this is just the principles. We're not going to get super geeky on you. The information's out there. If you've got questions, let me know, and I can kind of point you in the right direction. We can keep this simple, or you can get super, super geeky. And finally, here's your assignments for this class, this session. I want you to give me a brief description about yourself. I talked about myself. Tell me what your favorite beers is. What do you expect to get out of this course? What do you want to know out of this course? And I'll make sure we cover it. For actual work, I want you to compare and contrast 4 different beers with 3 different yeasts. When you're doing that, you must answer which yeast you would use and why. As I said in the previous slides, it tells you. Now, I want you to highlight the difference between the beer styles that are directly affected by the yeast. And then, if you've had any of these, tell me what you like about it, what you don't like about it, and why. And we'll see you in the next class.